Hello, and welcome to a lesson on inverse trig functions. Inverse trig functions. Okay, so like all things or most things in mathematics, most operators or functions, we have inverses as well. Okay, so that's true for sine, cosine, and tangent, just like everything else. So sine inverse, you'll see written, okay, like, oops, okay, like that with a little -1 up top. Same with cosine and tangent. That just means inverse of sine, inverse of cosine, inverse of tangent. Okay. You might also see it as arc sine, arc cosine, and arc tan. Okay, that's not very often, but still sometimes we might see some of that. Let's go down a little bit. So the original functions, if we're just looking at this table here, sine of theta equals some number, right? The previous lesson you saw fractions. Okay. So sine of theta equals some fraction opposite over hypotenuse. Cosine of theta equals some fraction. Okay, just a number. Okay, adjacent over hypotenuse. And tangent of theta equals opposite over adjacent. Okay, those fractions are just numbers, right? A number. If you do the inverse of that number, so if you look over to the side there, okay, if we go inverse of that fraction, that's actually equal to the angle. All right, that's equal to theta. Okay, so we can take inverses of those ratios and get out the angle. That's extremely helpful when we're trying to find angles in triangles or just angles in general. Okay, so that's true for cosine and tangent, of course, as well. So when should we use these formulas? When we're trying to find angles. Okay, if you can remember that, find angles, use inverses, it can be extremely helpful. Let's see some examples. Okay, so find theta, or just find the angle. Part A, inverse cosine of 1/2 is equal to blank. Okay, so in your calculator, there should be an inverse cosine button. Pulling my calculator out right now. It's actually just a little bit, it's the lettering above the regular cosine button. So if you hit the second command, and then hit the cosine button, I don't know if you can see that there, kind of hard. Right above, there's an inverse cosine. Hit that. Okay. Type in 1 divided by 2 or the fraction 1/2 and hit enter. You should get 60 degrees. If you don't get 60 degrees and you get some weird decimal, okay, it's because your calculator is in radians. Go find the mode button, click mode, go down, change it from radians to degrees, and then try again. It should work. Okay, or ask your teacher for some help. Okay, the next one, inverse sine. Go ahead and try that real quick. All right, you should have got -60. Okay, if you didn't, a couple things to check. First, make sure that your calculator is in degree mode. I should put units on these. We should always have units, degrees. Make sure you're in degree mode, but also make sure that you had a negative in there. Your square root, you're only square rooting the 3, not the whole fraction, just the square root of 3. And then the divided by 2 is on its own with not being square rooted. Okay, moving on. Okay, I find theta, and then use theta to find the other missing angle inside. Okay, so first of all, I labeled it because always, once you know what your theta is, it's always good to label the sides. Okay, so the opposite side of theta is 36 and the adjacent side is 10. We don't have the hypotenuse. So if I'm going to find theta, I need to use the trig ratio, okay, that compares the opposite and adjacent sides. I only have information for the opposite and adjacent. Okay, so which trig ratio compares opposite and adjacent? That's tangent. Okay, so let me set up tangent of theta is equal to opposite over adjacent, 36 over 10. Okay, so this is where we have to get theta alone. You can't just divide by tangent. Tangent is an operation. Okay, it's not a number. You can't divide by it. All right, we have to use the inverse tangent operation that we just learned. Okay, so I'm going to what's called inverse tangent both sides, and it looks a little bit like this. Okay, so I'm inverse tanning both sides of the equation. All right, so you look both of the things in red. It came from the previous line. All right. So the inverse tangent and a tangent just undo each other. That's the whole point of an inverse. Okay, it just undoes itself. So the tan and the inverse tan cancel, leaving me only with theta. Okay. And then inverse tangent of 36 over 10. Okay, that's what I need. All right. So I'm going to plug that into my calculator. Inverse tangent of 36 divided by 10. That gets me 74.47 degrees. Just going to make sure I'm in degree mode. I am. Okay, so let's just call it 74.5 degrees for now. Okay. Okay, then to find the missing angle, I just have to use the triangle sum theorem. That's from geometry. Basically, all it says is all the angles in a triangle add up to be 180 degrees. So 90 plus 74.5 plus our missing angle equals 180 degrees. So I just have to subtract 74.5 and 90 from 180. So 180 minus 74.5 minus 90. Oops, did that wrong. Leaves me with 15.5 degrees. So my missing angle is 15.5. And then it says find the other side as well. Okay, well, I'm just going to use the Pythagorean theorem for that. So I'm going to switch colors here. And real quick, do the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So 10 squared plus 36 squared equals c squared. All right, 10 squared is 100, 36 squared is 1296. Add those up, get 1396. And I just need to square root both sides to get c. I square root both sides, I get 37.36. 37.4, since I'm keeping everything on one decimal. There we go. This side is 37.4. There we go. Found all the angles, found all the sides. All right, we got a similar one. Okay. Find theta, and then find the missing angle and side. Okay, you can go ahead and right now try to find theta on your own. Hit pause. If you don't, you're going to see the answers real quick. Hit pause. All right, so I have the adjacent side. I have the hypotenuse. The trig function that relates the adjacent and hypotenuse is cosine. So cosine of theta equals 14 over 17. So CAH, C-A-H, adjacent over hypotenuse. All right, and to figure out theta, I just have to inverse both sides. Do that, they cancel. Okay, and then I'm left with theta equals inverse cosine of 14 over 17. If you punch that in the calculator, you're going to get theta equals 34.56 degrees. I'll do 2 decimals this time. Okay, so if I know that angle is 34.56, I can do 180 minus 90 minus 34.56 to get that missing angle. So I'm going to do that real quick. That gets me 55.44 degrees. All right, so this angle is 55.44 degrees. So find the missing angle. Now I just got to find the missing side. Again, we can throw down a Pythagorean theorem for that. I'll switch to purple for this. Okay, so a squared plus b squared equals c squared. Leg squared, we don't know that leg, plus leg squared equals hypotenuse squared. Okay, if I square 14, I get 196. If I square 17, I get 289. And then if I subtract the 2, I get 93. That's subtracting 196 from both sides. All I do is square root both sides to get x. And if I square root 93, that gives me about 9.64. That's my missing side. 9.64. All right, here we go. That triangle is done. Found all the angles, found all the sides. All right, here's a quick example. A painter needs to lean a 30-foot ladder against the wall. I drew it there. The red part is the ladder. Safety guidelines recommend that the distance between the base of the ladder and the wall should be a fourth the length of the ladder. Okay, so the distance here to here should be a fourth the length of the ladder. It will a fourth of 30. Let's just multiply it. 30 times 1/4. That gets us 7.5. So this leg of our triangle is 7.5. All right. To the nearest degree, what acute angle should the ladder make with the ground? Okay. So what's this angle? There's two angles here, but this one is not acute. That's not obtuse. So they want the acute one, or the one that's in the triangle for us. So we'll put theta there. And then they want to know how high up the wall does the ladder reach. We'll worry about that in a second. Okay, so we'll do height here in a second with Pythagorean theorem. But first, let's figure out theta. So I have the hypotenuse, and is 7.5 adjacent, or is it opposite? It's actually touching the theta. Okay, theta is using that side, so that would be the adjacent, not the opposite. So which trig function relates adjacent and hypotenuse?